Welcome to the lesson on exercise 6H, which is all about parallel lines and perpendicular lines. Now, parallel lines have the same gradient. Okay, so we can see an example of parallel lines on the screen, hopefully. And you can see three lines here, red, green, and blue, and they have the same gradients. They are parallel. They will never, ever meet. Okay. That's what a parallel line is. Parallel lines never meet. And we're going to be looking at these mathematically in a second. So that's parallel lines. Perpendicular lines meet at right angles. So if two lines are perpendicular to each other, then they will meet at right angles. Okay, they meet at right angles. Any questions? You can send it to me via chat if you don't want to be on the YouTube video, or you can unmute yourself and ask a question if you want. Just be aware it is going on YouTube, so it's up to you. Okay, moving on. Now, when we say parallel lines have the same gradient, what we mean is if you write the equation of the line in y is equal to mx plus b format, so if you have y is equal to 3 over 4x plus 7, say, and you have another line, which is y is equal to 7x plus 1. These two lines are not parallel because mx, the m, tells you the gradient of a line, and these have different values. They have different values. Now, if I wrote up another equation of a line, y is equal to 7x plus 5, let's say, then I'll use a different color highlighter. This is 7 and this is 7. And because they have the same gradient, we can say that this line and this line are parallel. Okay, they're parallel because their gradients are the same. And on the other hand, if you happen to have two lines which are parallel, then in reverse, we can say they will have the same gradient, they will have the same m value. If you wrote the equation of this line and you wrote the equation of this line, they would have the same m value. So as you can see over here, we scroll up a bit. Red is y is equal to 3x minus 1. Now the green line is going, the red is 3x plus 3. Red line is 3x plus 3, and I'll code it in red. That is the equation of the red line. Y is equal to 3x plus 3. It's meeting the y-axis at 3. The gradient is 3. Now, if you look at the green line, the equation of the green line is y is equal to 3x minus 1. Notice the gradient is the same. And obviously, the blue line is also parallel. And so the blue line has the equation y is equal to 3x minus 4. And it will have gradient 3 as well. M will be 3. All three of them have the same gradient. That's why they all have the same m value. And we'll do some worked example in a second. Let's look at perpendicular lines. This one's slightly trickier. Perpendicular lines have gradients which are negative reciprocals. Negative reciprocals. So what does that mean? When two lines are parallel, let's say, for example, this is the equation of one line, 5x minus 10. Then the line which is going to be perpendicular to this, the line which is going to meet this line at right angles, it will have a gradient which is going to be negative reciprocal. You flip this upside down. Reciprocal means flip upside down. So 5, we can think of 5 as 5 over 1. If you flip it upside down, it's going to be 1 over 5. Negative 1 over 5x minus 10. And let's look at another example. If you had y is equal to 3 over 4, and let's make it negative this time, plus 3. The negative reciprocal of this, the line which is going to be perpendicular, the line which is going to be perpendicular is going to be negative of negative, which is positive. So it's going to be positive. And you flip this upside down. So 4 over 3x. And the plus can be anything. It doesn't really matter. We can write 7. It doesn't matter. These two lines will be perpendicular. So if it's negative, the perpendicular line will be positive. And if the original line is positive, the perpendicular line will be negative. The gradient will be negative. Okay. So hopefully that's clear. And then you just flip the gradient upside down. You flip it upside down. So perpendicular lines have gradients which are negative reciprocals of each other. And let's look at, I think it'll be clearer if we look at some worked examples. Remember, you can send me a question anytime via chat, or you can unmute yourself and ask a question using your microphone. But be aware, I'm recording this, it's going to go on YouTube. So you're more than welcome to, but just be aware of that, okay? And if you don't want your voice on YouTube, just send me a chat message and ask a question there. All right, so let's look at this. Decide if the graph of each pair of rules will be parallel, perpendicular, or neither. All right, so we have y is equal to 4x plus 2, and you have y is equal to 4x minus 6. And the only thing we're going to look at is the mx value, the m value. And over here, we see the m values are the same. And when the m values are the same, the gradient is the same, it's parallel lines. Parallel lines. These lines are parallel because their gradients are the same. They both have a gradient of 4, and therefore they're parallel. Then we look over here, and once again, you focus on the number next to x. We're focusing on the number next to x, right? And are they the same? They are not the same, so they are not parallel. Okay, not parallel because the gradients are different. Parallel. However, we notice that -3, and if you flip this upside down, you can think of -3 as -3/1. If you flip it upside down, you get 1/3. And that's negative, that's positive, and therefore they're perpendicular because they're upside down versions, and one's positive, one's negative. That's the rule, right? They're perpendicular. Perpendicular lines. These two lines are perpendicular to each other. Let's move on. Find the equation of the line given the following description. A line passes through 0, 2. So let's just draw it up. It'll help us think through it. So this is part A. Line passes through 0, 2, 0, 1, 2. Line passing through there and is parallel to another line with gradient 3. It's parallel to another line with gradient 3. Now, this other line has a gradient of 3. What that means is this other line is going to be y is equal to 3x plus something or other, or minus something or other. We don't know. That's not really the point. The point is it's 3x. It's got a gradient of 3. And the line we're trying to find the equation of is going through 0, 2, which is the y-intercept. So remember from the previous lesson, to describe any line, you have to fill in these two values. What is the gradient? Well, the gradient is going to be 3 because it's parallel to a line with gradient 3. And so y is equal to 3x. And then now we have to write the y-intercept, and that's plus 2 here. So plus 2. And that's it. That's the equation of the line. The equation of this line, because it passes through 0, 2, that tells us the y-intercept. And it's parallel with the line with gradient 3. It tells us the gradient. It's parallel, therefore it has the same gradient. So gradient is 3. And so the equation of the line being described in part A is equal to y is equal to 3x plus 2. Now we move to part B, and I'll use a different colored pen. And B is going to be in red. A line passes through 0, -1. So the -1 is there, and that's obviously the y-intercept. And so we can write straight away y is equal to something x minus 1. It's going to be minus 1 because it's going through the y-axis at -1. So -1 there, right? And it's perpendicular with another line with gradient -2. So it's perpendicular, which means that the gradient of this line is going to be negative reciprocal. Now, since this is already negative, our line is going to have a positive gradient. You don't have to write the positive. I'm going to write it anyway, just to make it very clear, because the line which it's perpendicular to has a gradient of -2. And then now I flip this upside down. 2, we can think as 2/1. And so flip it upside down, you get 1/2. And that's 1/2x minus 1. And that's the equation of the line. Half x minus 1. And we're done. Moving on. The last worked example for today. Find the equation of the line that is parallel to this and passes through there. Okay, so let's have a look. Sorry about that. All right. So find the equation of the line that is parallel to there and passes through 1,9. So let's see. Let's just graph it up. It's parallel to there. We have to find the equation of the line. So y is equal to, because it's parallel to this line, it's going to have the same gradient. So the line we want is y is equal to negative 2x. And then now we just have to figure out the y-intercept. And passes through 1,9. So we're going to write y is equal to negative 2x plus b. We're writing y is equal to negative 2x. Come on. Plus b. Now I know for a fact that it passes through 1,9. Now 1 is the x value. 9 is the y value. And because the line passes through 1,9, I can substitute these coordinates into the line. The left-hand side will equal to the right-hand side. And so I'm going to sub in y is equal to 9. So y is equal to 9. I'm going to write 9 there in place of y is equal to negative 2. And in place of x, I'm going to write 1. 1 plus b. And then now I can just solve this equation to find what the value of b is. I expand the brackets. Negative 2 times 1 is negative 2. Right? So nothing's changed. I've simply expanded the bracket. And now you have minus 2 on this side to get rid of it because we want b to be by itself. We want to know what b is equal to. I can add 2 to both sides. I can add 2 here and add 2 here. Minus 2 plus 2 is going to cancel out. And you have 9 plus 2, which is 11, is equal to b. And that's the, so the equation of my line is y equals to minus 2x and b is 11. So plus 11. And I'm done. And this one is a bit more involved. It's a bit longer than normal, I guess. So if you have any questions, make sure you send them to me via chat. I'm doing part B now. We have to find the equation of the line that is perpendicular to that line. So perpendicular to this line tells me the gradient. And the gradient is going to be negative reciprocal of this gradient. The negative reciprocal of that is negative 4. You flip it upside down, the 4 goes on top, 1 goes to the bottom. 4 divided by 1 is just 4. So we have y is equal to 4, and it's going to be negative reciprocal. That's a positive, so our gradient is going to be negative 4x. And then now we have to figure out the y-intercept. We know it passes through this, and so we can sub these points in. We can sub this coordinate in. That's y, that's x. And so in place of y, I'm going to write negative 2. In place of y, I'm going to write negative 2 is equal to negative 4. And use brackets anytime you sub in. In place of x, I'm going to write 3 plus b. And the left-hand side, we can do this because if a line passes through a point, then you can sub that point into the line, and left-hand side of the equation will equal to the right-hand side of the equation. That's exactly what we've done. We've subbed this point into this equation, and we know for a fact that the left-hand side of the equation, minus 2, is going to equal to the right-hand side of the equation, which is negative 4 multiplied by 3 plus b. Anyway, solving this, minus 4 times 3 is minus 12. So I haven't done anything except for expand the bracket. And then now I want b to be by itself. So I have a negative 12 here to get rid of it. To undo it, we do plus 12 on both sides. If you do it to one side, you do it to the other side. And so you have that cancels out. Negative 2 plus 12 gives you 10. 12 minus 2 is 10. That's what b is equal to. I can sub this value of b into our original equation because I know what b is now. Y is equal to minus 4x plus 10. And you're done. That is the equation of the line. So I'm going to end the recording here. If you have any questions, if you can ask me on Slack. And for the people who are here, you can ask me now. I'm stopping the recording.